Now? Okay, good. Welcome, ladies and gentlemen, to Silent Disco about AI. Yeah. Actually, I am here with one of my favorite executives out of the UAE, mostly because he's driven so much innovation in this space and also has quite a bit of control over that. I'd like to introduce to you Dr. Najwa.
Yes.
Yeah. Najwa Aaraj, the CEO of TII. But maybe you can better explain what TII and your role is there.
Yes, so first, thank you, Werner, and thank you for AWS Summit for having me here. Thank you for your patience as well. Thank you for Tanuja's patience, because I've changed the schedule quite a few times, but finally I made it here, which is good.
Given that
Great.
you're on Silent
Very
Disco,
good.
all of you, but I'm not.
I think you can hear me, right? Okay, awesome.
Now they can hear you, but not.
Great, great. Now you can hear me as well?
Now I can hear
Fantastic, very good. The Technology Innovation Institute is part of the Advanced Technology Research Council, which is a council that was formed in May 2020 with the main mandate of driving R&D and establishing a whole R&D ecosystem in Abu Dhabi. TII is the applied R&D arm of ATRC. In addition to TII, we have two more entities. One is Aspire, which does the business development and program management and looking into what are the use cases which can be benefiting from the technology that we develop, as well as Venture One, which is the commercial arm. In TII today, we build the technology, we reach prototypes in the lab. One very important aspect of what we do is we deploy in operational environments, and when the technology is ready to be commercialized, it's pushed through Venture One, either through licensing or through startups. Today, through Venture One, we have established 4 startups. One of them is AI71, and I do believe Tanuja earlier announced the collaboration or strategic partnership between AWS, TII, and AI71, and we have Chiara here, who's a chief AI and product officer in AI71. In addition to AI71, we have 3 more startups that were established a few months ago. One of them is called Quantum Gate, which we're driving all the post-quantum crypto and identity and access management offering through that. We have another startup called Steer AI, which is a company or a startup focused on autonomy for ground vehicles. And the last one is robotics for climate tech. It's called Nabat AI, which use swarms robotics in order to do ecosystem restoration, and in particular mangrove seeding, mapping, and monitoring in the country and at a global level. Okay, so that's in a nutshell who TII, the whole ATRC ecosystem is.
I know not everybody here wants us here to talk about AI, but I assume you've heard about AI all day.
Yes,
already.
Indeed, actually, yeah.
and more than that. You mentioned one thing, you mentioned quantum.
Yes.
So quantum is a pretty unique research field. And I think the area where we've heard most about, next to building hardware, is whatever role quantum is going to play in security.
Yes.
Yeah. Can you give us a little bit of insight what your thinking is about the impact of quantum, not only on encryption, but just security in general?
Yes, so maybe allow me to speak first about the impact of quantum in security, right? Today, there's a race globally to develop the quantum computing hardware. And the number of algorithms that are known to be running efficiently on potentially large quantum computers is not that high. But there is a quantum algorithm, which is called Shor, which basically threatens the security of all the public key encryption that we have today. So when we go to a website, when we browse, and there is HTTPS, anything that's using certificates, all our VPN boxes, all our communication applications where you have to do certain key exchange, all of these algorithms will be broken. And these algorithms are the public key algorithms, RSA and ECC. Today, we rely on the hardness of 2 fundamental problems, which is integer factorization and discrete log. These in complexity class will be broken by the quantum computer. So meaning that 70 to 80% of our crypto today will be broken. And this is where the whole concept of post-quantum crypto, which basically is trying to find algorithms for a key exchange. In the post-quantum world, we call it key encapsulation mechanisms, and digital signatures where the foundational math is not broken by quantum computers. So these are initiatives that have started a long time back with Kyber, which is code-based. And then you see NIST has started from 2016 with the competitions to find standards for CAM and digital signatures. Last year or the year before, they put another call for signatures as well in order to come with the standards that should be adopted for quantum safe security. Now, the reason why we are looking into them today is we're worried about passive quantum attacks. The quantum computer that would break crypto does not exist today. It has to be around 1 million qubits or 1,000 logical qubits, and this is expected between 8 to 10 years or even more. However, if you think about government entities, critical infrastructure, they all do store information, and this information, once the quantum computer is ready, you can go back and attack it and reveal all state secrets, infrastructure secrets, etc. So this is where the whole store now, decrypt later threat comes from. This is why there is a very big advocacy to start into this post-quantum migration. And we are in a country where they are very well aware of this problem. There was a law last year and an executive regulations that came up in order to start with those post-quantum migration, and the Cybersecurity Council today is responsible for that. So now this is the, let's say, the threat on encryption. If we talk about,
can I stop you there for 1 second before
of course you can.
So if I can make a little sort of summary here, is that don't wait until the hardware quantum computers are there to start thinking about your security infrastructure at that moment. Yeah? AWS already has made open source a number of what we believe are quantum safe encryption algorithms, but you should not wait till 10 years from now to think, then's when I need to start looking at it. Yeah. You might as well start employing those techniques now today. Sorry, was this my advice to customers?
No, it's actually a great advice, and another thing is the migration will need time, right? And this is where the Moscas theorem come into place as well. Now, as an impact on the overall cybersecurity theme, we can think about pros and cons, right? In terms of cons, things like malware generation, obfuscation of malwares, and all of this will become much more, it will become exponentially sped up with quantum computers, right? At the same time, incident response will be more manageable. Feeds and then the analysis of the feeds and then coming up with patches for systems, for network, etc. will be sped up given the computational, let's say, acceleration that quantum computers will come up. There is a very big, going back to AI, I don't think we can speak without putting AI in the picture, right? Today you see a lot of vulnerability management systems, exploit detection, binary analysis that are relying on LLMs or AI, etc. Yeah. So this also will have a big potential when quantum computers will be into play.
The thing is, of course, on both sides, it's the good actors as well as the bad actors.
Absolutely, yeah.
And actually, the bad actors have a little bit of an advantage because they hire more PhDs, pay better salaries, software only needs to work for 10 minutes.
And they're crystal clear on what they're doing, exactly.
Yeah, and they have all the advantages.
Absolutely.
So okay, so I know you're in this room here to hear us talk about AI and culturally AI and things like that. We have to actually congratulate TII on basically launching the first non-English, can I say that?
Yes.
Open source LLM on AWS, trained on SageMaker together with AWS. Why did you guys go that direction?
So before I come, just a parenthesis, and today we have announced and released a new model that was also trained on AWS, which is Falcon 34B H1. It's unique in a sense that it is a hybrid model. It is a Mamba plus transformer-based model, so it's a hybrid architecture. It is, of course, topping the leaderboard as we are used in all of the Falcon series that was released, and with a performance that is even better than let's say, models that are twice the size, right? So this was released this morning. His Excellency Faisal Bannai, who's the Secretary General of ATRC, announced it in his talk and make it in the Emirates. So this was very special because Falcon is made in the Emirates. And the other announcement was we have enabled API access to Falcon Arabic, right? And Falcon Arabic is it's a Falcon 3 that was extended with Arabic capabilities. It's pretty special. It has been trained with native Arabic and it is performing as the best Arabic model that exists, right? So to go back to your question, let's say the decision to deliver Falcon, of course, it has been multiple aspects, right? So since April 2023, we have started releasing the Falcon series of models, large language models, multimodal models, transformer architecture, Mamba or SSM architecture, or a hybrid architecture that we released today. Initially, the models were done as a research programs, and initially also there were not that many models that were open source, right? So it has been released as large language models, not really production ready, but we released them in order, one, to have sovereign models, and the second one, in order to start bridging the gap between closed models, and the majority were closed at that point, in order to enable access for the entire community to start exploring with LLMs, looking into how do they function, into architecture, in order to start using them in actual use cases. And as we progressed and we mature, today the Falcon models are production-ready models. These are models that can be deployed in solutions, that can be deployed in to solve specific use cases. The more we are releasing, and if you look into the history, the models now, they are more performant even though they have smaller sizes. So we're focusing a lot on data quality, on data processing, etc. There is a lot of optimization in the training pipeline that is happening as well. And the more and more we will be growing, we will also be specializing the models more. And I mean, we all are very familiar with this curve of AI, right? Which I really love, is moving from these LLMs to more focused and, let's say, smaller sizes, large language models and VLMs, moving into agentic, and then really moving into the physical AI. And hopefully by the second part of the year, you will hear a lot of announcements of those specialized models from TII, especially in the robotics field.
Oh, very cool.
Yeah.
I think one of the topics where there's always a lot of discussion about this is, responsible AI, ethical AI. Well, I personally have an objection against the word using ethical, because it's so cultural dependent what is ethical and what is not ethical.
Absolutely.
Yeah. And if you look at things that our parents never would allow, would never thought possible, like in vitro fertilization or things like that. Or maybe our grandchildren are going to be extremely angry at us for not modifying that one gene in the womb that would cause them cancer later. So ethics is a difficult one, but responsible is something else.
Yes.
Yeah? And can you talk a bit about how you look at responsible use of technology?
Yeah, so I mean, you rightly said it, right? So ethics, regardless of how many regulatory sandboxes you deploy models in them, you will never find a common or universal definition of what ethics is, right? You can always train the model from a, let's say, training perspective, that you can reduce the bias, you can put guardrails in it, etc., but this can never be universal. Mm-hmm. Now, from our perspective, in addition to the development of the models, there is a lot of work that's happening on the safety, on the privacy, and the security, and the responsible use of AI, right? In fact, one of the components of this strategic partnership that we have with AWS is not only the development of models and training of models or hosting Falcon on Bedrock, but also we're collaborating on two very important technology solutions and research topics as well. One of them is private AI. So this is looking at how can you preserve the privacy of data when you're training and also when you're doing federated learning. And this is one of the solutions that we're launching with you today, which is called BetterGuard, which is privacy preserving federated learning. And the second one is looking into homomorphic encryption and fully homomorphic encryption, and then how it can be helpful and useful in AI and large language models and models in general, right? Then there is the other aspect of how can I, so this is on the privacy preserving and the security side. Then you have the other aspect of how am I curating and pre-processing my data before I feed it into the model, train it to make sure that I have good quality output that adheres to specific standards and responsibility, etc. And then, of course, there is the other one, which to me, probably this is where responsible usage of AI happens, and I spoke to it a lot before, is when you start talking about GANs, if you start talking about deep fakes, and you start using of the misuse of models, right?
Yeah.
And there, if you think about it, it's a chain that is not only the user, it's not only the model owner, it's not only the application where you actually publish certain elements that are the results of these deep fakes or of the GANs or what we call it. And this is where you will have the entire ecosystem that has to deploy a solution end-to-end in order to be able to detect, to protect, and to fight that.
Yeah. And actually, one of the things that we're doing at AWS or at Amazon for a long time already is it's an area of AI that hasn't been talked much about, but it's what's called automatic reasoning. Yeah, which is not the same as language models or things like that, but it is, for example, we use AI, automatic reasoning, to protect your outputs of your LLMs.
Yeah.
The easiest thing to think about that is that imagine a triangle. Yeah, we all know what triangles are: a square plus b square, c square. Yeah, and so, but an LLM is a textual model. It doesn't know what triangles are, and it may give a wrong answer if you ask it what a triangle is. However, automatic reasoning knows about can reason about all the triangles in the world, and at some level, then look at the output of an LLM and say, this is a triangle, this is not a triangle, and so. This is a unique case where one form of AI is being kept in check by another version of AI, almost. And actually, just for you in the room, we have been using automatic reasoning probably for the past 10, 15 years, especially in AWS, for things like, can we prove to you that the tools that we've built to keep you secure actually are keeping you secure?
Absolutely, yeah.
Yeah? Can we prove to you that if you have one VPC here and one VPC over there and you have flows between them, can we prove to you that there is no other traffic flowing than only those? Sorry.
No, it's actually fantastic. This is, in the security world, this is what we call the formal proofing and verifiable computation, right?
Yeah.
And this is where automatic reasoning, it's a very good point.
Absolutely. So if you think about, I mean, we're not thinking about generic applications of AI and things like that, but especially those, let's say, AI sites that are more concerned about culture. How do you I mean, I find it already very hard. As people 2 years ago have asked me whether I would be sitting here and talking about Gen AI, I probably wouldn't. Do you have an idea, or what's your goal? Where would you like to see this go? You know, where do you like to see sort of the next generation of development of AI go?
So, look, if we look as an institute, how we have evolved our roadmap, right? Starting from the release of LLMs in the open source in order to enable the access, in order, as you said, in order to enable localization and then fit for specific context when, you know, like in the hands of whoever has them, into the development of stronger models, more performant models that have, that always have scored high on leaderboards, to the development of models that score very high in reasoning capabilities, and now moving into the more specialized models, the models that are tailored for specific use cases, I think this is the road that we will be going to, right? Today, if you look into the world of robotics, the world of humanoids, robotic arms, robo-dogs, all of these are moving from the traditional, I control you using reinforcement learning and I put a neural network on you, to be controlled pretty much with very large models, with action VLAs, vision language action models, with coded policy and others, right? So you see the specialization of those large language models in order to start controlling these robots, and in fact to start controlling them in a universal way. So the same VLA that can control the humanoid to do a specific use case, from doing chores in the kitchen, to doing chores in the warehouse, to doing chores in the house, to doing chores in the construction industry, to actually move it to a system of multiple robots or to quadrupeds or to robotic arms, etc. So this is one of the applications. Another use...
Yeah, sorry, no. Just a joke. Oh, no, it's not really a joke. Do you guys know that more than 3,000 years ago, the first robots were described already to do the household chores? Plato in the Republic describes this.
Yeah.
And so this is something that we've been thinking about for 3,500 years now, and we're getting closer.
I think we will get close. We will get close soon, right? Then you have all these. Let's say the cybersecurity, for example, can be a perfect consumer of LLMs, right? With all the CVEs that are out there, with all the databases that are out there, whether we're talking about OWASP, MITRE, etc. Imagine a model that takes knowledge graphs that represents executables or binaries or whatever, and then you train it on all what could be a logical control data flow of an application and something that can detect an anomaly in that or an exploit in real time, right? So how much can you save in static analysis or code analysis or binary analysis, etc. Another field, and then you have the, let's say, the verticals and all the fields that can benefit from AI. What healthcare can benefit from these solutions, what construction can benefit from these solutions, and this is what Chiara and the teams have been focusing on, is how to take these models and then specialize them in order to fit specific use cases and specific verticals.
No, definitely healthcare. If you ask me, so my favorite area, I think, of applying AI is probably healthcare. I think there's so many things we can do there that weren't possible in the past. Take an example as Lou Gehrig's disease, ALS. Yeah? Very terrible disease, but there's not enough people suffering from that disease.
Absolutely.
To motivate life sciences companies to start pouring billions of dollars into research to find solutions. We may now have an opportunity to have technology do that for us instead of having these companies to do this innovation. Or even there's this program, I think this program in quite a few places in the Western world where women over 50 can get a mammogram every 2 years to avoid to early detection of breast cancer. The Swedes, people in Sweden actually have put one radiologist to look at the imagery and have AI look at the imagery. AI finds 30% more cancers. And it's not because the radiologist is bad, it's just he looks at 1,000 images a day. At the end of the day, his eyes are tired.
Yeah, exactly.
All of these kind of things. I just was at a university in Vietnam, and they've made a little app on your phone where if people suspect that you've had a microstroke, that is not something where half your face is hanging down, but it may be. Just taking a little video, and within 30 seconds you can determine whether you should send this person to the hospital immediately right now. So I think that the area of healthcare is huge.
Absolutely.
Yeah. So with all of that, thank you very much.
Thank you very
for
much
being
for having
here.
me. It's a great discussion, great conversation.
Yeah.
Thank you.
And actually, I hope to come visit you soon. So
You're-
with that,
you're
thank you
most
very
welcome.
much, Dr. Najwa.
Extend an invitation
and
today. Thank you very much.
My pleasure.
Thank you.
Thank you.